Welcome. Today let us solve Leetcode 3152 Special Array 2. An array is considered special if every pair of its adjacent elements contains two numbers with different parity. So that just means basically that each element in the array or list alternates between odd and even. And then they will provide a queries list, and for each inner list, for the queries list, they want to know if that list or arrays associated with these endpoints is special. Okay, so let's walk through this here. So 0 to 4 is the query, so they want to know starting at index 0 to index 4 inclusive if every element follows, or if this array defined by these bounds is special. So from 3 to 4, that's good because 3 is odd, 4 is even. 4 to 1, that's good. 1 to 2, that's good. However, 2 to 6 fails because both 2 and 6 are even. So that would make this query result false. And that's basically it to the example. So I think we can start with an algorithm, how we'll solve it. So I'm actually just going to use that example again, but go over how we'll solve it. Okay, so we're going to, in essence, use, in a sense, dynamic programming. So what we're going to do here is something like this. We will store the start and stop value for parities. Okay, what do I mean by that? So let me show you what I mean by that. So what we're going to do is just make D for now. And D will be equal to 0, 1, 2, 3, 4. I think that's it. So right now I'm setting L equal to the length of nums. So right now this is that. In essence, I could have, in Python, I would have written something like this: list range L. So L is what, 0, so 1, 2, 3, 4, 5. So range from 0 to 4. So this is essentially this in Python. So what does this mean? What does this D represent? This D represents where I can start and stop, and it works. So what I mean by that is this 0 index stops at 0. Sorry, it starts from 0 and it ends at this 0 index. This one, sorry, it just means that you start and stop at the same place because they're equal. So this 0 value is the same as the index. This 1 value is the same as the index, so on and so forth. So what we're going to do is build this array. We're going to build it, and so as we build it, it'll become more clear what I mean by that, hopefully. So what we're going to do is we're going to start from here. We're going to start from here. So start from this here. And what we're going to say is, if we look back 1, so I'm going to say, I'm going to compare D of 1, and I'm going to ask myself, okay, is the parity, is it, for now I'll just do this, is that different from looking back? Sorry, let's use this, nums. So looking at numbers, so nums, is this number different parity than this number? So that's what I mean by this thing here. This I just use this here for now, and we'll use a different approach, or like a different operator during the implementation. So I'm asking you, is this 4 different from this 3 in parity? And I'm just checking just from the 1 to the 0. Maybe it'd be better if I just put 0 here and a 1 on this side. If that's true, then we use this one. So then we say, okay, that's true. So then we update. D of So I change this to be whatever this is. So now d of 1 equals d of 0. So sorry, let's write that better. So notice how if they are true, so if different parity, then we do this. So if 4 and 3 are different parity, I say, okay, I update me to BU. So that means, now what does this mean? So D, what does D look like now? So D now looks like this. It looks like D would equal 0, 0, 2, 3, 4. Now that means if we're at the first index 1, that means I'm good. If you start at index 0 and end at my index at me at 1, we're good to go. We satisfy the different parity. And then we do the same thing again. But now we look at 2 and 1. So looking at 2 and 1, let me maybe make this smaller now. So 2 is 1, and sorry, the index at 2, sorry, the value at index 2 versus the value at index 1. So they're different. They're different parity. So sorry, let me update this. So that means d of 2 equals d of 1. Well, remember d of 1 equals 0. So now I update d of 2. Now this is 0. So now what does this thing represent? It means if I go to this index 2, this array tells me that I have different parity all the way starting from 0. So that's what this means. And we'll just continue on building it like this. Moving on. So now we're comparing 3 and 2. So numbers at 3, so 3 is even, and at index 2 it's odd. So they're different parities, so that means we can update. So now d of 3 equals d of 1. Sorry, d of 2. Well, d of 2 equals 0, so that means this changes to 0 now. And well, what does that mean? That means that at index 3, this is at index 3, if you start from 0 to index 3, you're good to go. You're different parity all the way through. Okay, fine. Very good. Moving on, same thing. Now we compare 3 and 4. Now, they're not different parity. They're both even. So that means this doesn't happen. So this doesn't happen. So it stays the same. So I don't know. I'll just comment it out just to indicate that it doesn't happen. So that means, well, what does that mean? So it means at index 4, starting at 4 is where we're good to go. But other than that, this array means, for example, let's pick any index. This means that, so this is at index 2. At index 2, this means starting at 0, ending at index 2, we're good to go. If we move over, starting at index 0, which is here, the value here, to the index, which is 0, 1, 0, 1, 2, 3. So 0 to 3, all the elements have different parity. And that's basically the approach we're going to use to solve it. And well, I think it'll become, okay, so then when we run through the queries, let's maybe go through the query here. So the query was a 0, 4, right? So let's go for how we'll use this to solve that. So here, I'll just put it down here. So then we'll check, so we'll run through the query. So then so I guess 4, start to stop in queries. So what we'll do is we'll check. We'll say, okay, d of stop, is that less than or equal to start? So let's think about that. So they want to know if we stop at index 4 but start at 0, is that does that satisfy the parity requirement that they require? So remember, at d of stop, so remember where this is the current state of our array that stores our where we start and stop. So at index 4, so d of stop, so d of, this would be, in this case, it would be d of 4. Is d of 4 less than or equal to the start? So d of 4, 0, 1, 2, 3, 4 is 4. And 4 is not less than or equal to 0. So that means this would be false. And that makes sense, right? So the reason why it makes sense is because we're only starting at 4 and ending at 4. Well, a good question is why would this need to be less than or equal to? So that's a great question. So what if we had something like this? What if, let me make something like this. 1, 1, 2, 1, 2, 1, 2, 1, 2, 2, 1, 2. And then we built our array. If we built it, that means everything would be, it would just grow all the way to it. Sorry, actually it would be zeros all the way through, sorry. So if they asked us something like, for example, let me make my own example. If they asked us something, okay, the query is going to be from 3 to 7. And then using this technique, okay, let's use this technique here. Let me just copy this up. That would mean, okay, so d of stop would be d of 7. Is that less than or equal to start? So, well, yeah, in fact, d of 7 would be, so 0, 1, 2, 3, 4, 5, 6, 7. This is 0. So yes, my point is, so they're only asking if it's good to go between 3 and 7. But this says, I'm even better than that. You can even go back 2, 1, and 0. You can go back 3 more spaces, and we're still good to go. So that's why the less than or equal is required. So the equals is the minimum, but you may, as in this case, notice how if they give us 3 and 7, we need the less than sign, because so 0, 1, 2, 3, 4, 5, 6, 7. So all the way up to here is good to go, but they're only asking from here. So since this value is less than that, that makes this okay. So I wanted to make that point, just because it's very subtle. Okay, I think that's enough for us to get started. Let me comment that out. Probably should delete it. I will shortly. Okay, let's get started. So we'll first start off with setting up our D list for storing where we start and stop as far as parity is concerned. So we'll set list range and maybe the length. So we'll do, I guess we can use length of nums. Length of n. Okay. Sorry about that. And then now we loop. Remember, then we need to create this. We need to do this like we did here. Remember, we created this dynamic array to store. We compared the previous value, the current value, and the previous value. So let's do that. So what we do is we loop for I in range. Actually, I'm going to redo this here. I'm going to say n equals length of n. Here. Then I'm going to do n 1 to n. There we go. Then I compare if nums I mod 2, if that's different from nums I minus 1 mod 2. So that means they're different parity. So that means we can do like we did here, where we adjusted our D array or list. So we say, okay, D of I equals d of I minus 1. And we're just going, this is how we build it. Okay, great. And that's it. This will essentially build this array that we'll use for the queries. Okay, now we loop through the queries. So the queries, so we go from start to stop in queries, and then we say, sorry about that, if d of stop, if that's less than or equal to the start. And if it is, well, we can append it. So, well, let's make a result here, and we'll just do something like, okay, result dot append. Actually, I'm gonna do this here. We'll just do this here. True, just for now. I might clean it up a little bit afterwards. Result dot append false. And then we can return result. And let's check it. Invalid syntax. From start, stop, in. Oh, sorry, I wouldn't know what I was doing there. For start, stop, in query. There we go. Num is, what did I do wrong? Oh, yeah, I didn't use nums, I used n. Sorry about that. Okay, it looks good. And let's submit it. I may adjust it a little bit just to see how it goes. Okay, that looks good. Okay, that looks very good, right? So let's see what else we can do. And I think that's a very, very good score, but let's see what else we can do. Okay, so let's first erase these comments. We don't need them anymore. And I'm gonna do something here. First thing off is I'm gonna alter all of this here. So I'm gonna do this here. I'll leave it there. So I know I still need to do this. Let's do I know I need this. Let's copy that. Maybe I'll do that's fine. We can do it like that. And we'll do this here. We'll say d of stop less than or equal to start, and we'll just make this an array, and we'll just return it. I think that's equivalent to all of this madness here, and let's just check it really quickly. Okay, all right, and then let's make another change really quickly. So one thing I like to do is sometimes I like to use bit manipulation instead of using this approach. So let's try using a bit manipulation. So what we can do is we can do something like if n I XOR n of I minus 1. So if we have an odd and even, and then we perform an AND with it. So if this is odd and even, this will be if it's odd and even, it'll be, and you XOR it, it'll be true. And then 1 and 1 will be true. So that means we go in here. So let me say that again. So if we have something like 5 XOR 4, this would equal true. This equals, well, it would equal something true. Because remember, 5 looks like, what is it, 1, 0, 1, and XOR would be what, 1, 0, 0. When you XOR this, you get something like, you just get 1, in fact. This equals 1. And when you do 1 and 1, well, 1 and 1 is true. So, and then that would allow us still to perform this update. So I'm just going to go with that approach. Just sometimes I like to do bit manipulation instead of the other math operators. I think bit manipulation is a little bit lower to the machine, so it provides a little bit more optimization or performance, a little bit better performance, because you're performing a machine operation, and machines like doing basic, real basic operations. Okay, and I think that's should be good to go. Let's see how this affects the result. It may or may not. It may or may not. Just something I would do. Okay, I made it worse, but oh well, that's fine. And I'll just try it again, and for the hell of it. Other than that, I hope you have a great day. It's getting worse and worse. If you like this, or if it was educational, please consider liking or subscribing. Have a wonderful day. Take care of yourself.